So, hello everyone, how are you all? I hope you all are fine and safe. Well, again, welcome back to Quantum Mathematics. I'm Aman, just welcoming you all to a new amazing video. Well. If you have watched the latest video of mine in which I have proved the Gaussian representation of the gamma function, so in that video, if you have watched that video till the end, so you can think of everything is same. Yeah, right. Actually, and I have just I didn't change my clothes. Actually, I just finished recording that video, and now I'm thinking that let's just consider making this the Weierstrass infinite product video here now immediately, because they both are actually not they both, but this product, this representation of gamma function is depending on this relation. So that is why I think let's just prove this down right here. So yeah, I'm here, and I think let's just formulate that, right? And yeah, this is really amazing. Just have a look at this crazy looking relation, that is 1 over gamma of z equals z times e to the Euler-Mascheroni times z and times the product as k goes from 1 to infinity of 1 plus z over k and times e to the negative z over k. Actually, in my previous video, I have written this on my whiteboard. Actually, this is what that is like being visible right in front of you all if you have watched that video. So I have just proved it unoffice like on off camera, right? So I was just practicing of it, right? So basically, if you can understand all these stuffs by your own, so that's a fantastic thing. But if you're having any kind of trouble understanding this all, so I'm here. After watching this video, you will not have any kind of problem understanding that. So I think I should begin just the proof. So here it comes, guys. Okay, so basically we have proved till now that gamma of z equals limit n tends to infinity of n to the z over z times the product as k goes from 1 to n of k over z plus k. Okay, now we're just going to begin our proof from this relation only. So I'm just going to take a look at this function. It's n to the z. Okay. So like how would I able to oh, I think it's wait a second. Yeah, it's good. So how would I able to actually I thought that it was z to the n, but yeah, this is the right thing, n to the z. So I can replace it, or I can just represent. Okay, again here comes the thing that you might have remembered, because I told you to just write that down in your notebook if you are writing something in my from my video. And the thing was, in my sophomore dreams video, I told you to just take care about this term, this thing actually. So again, we are going to use this down here itself again. So that is why I told you guys, this is really important. Okay, so we can just replace it with, like, let's consider this, like this symbol is representing n to the z. So this can also be written as e to the ln n to the z, or basically with the basics of natural logarithms property, so we can consider it writing as e to the z ln of n. So yeah, fine, let me just erase this down here a little bit, and then we will continue here from here itself. So here it comes. So basically n to the z is being represented with that. Okay, now I can say n to the z equals e to the z times ln of n. And I'm just going to add z times h sub n and minus z times h sub n, because eventually they was going to be cancelled out with each other and we would have this very function or this very term, right? Okay, so basically what h sub n here is, h sub n is harmonic series. What's our harmonic series is h sub n equals the sum as n goes from 1 to, oh, I'm sorry, I think I consider writing it as k goes from 1 to n of, it's I think 1 over k. Yeah, this is the harmonic series actually. So you can just write that down if you want, or maybe we can just replace it with that. K goes from 1 to n of 1 over k. Okay, so actually we are doing this because we are just going to introduce the Euler-Mascheroni here, and yeah, that's fine. So n to the z again can be written here as e to the, I can write this as negative z of h sub n minus ln of n. Actually what I did here, don't get confused, I considered these two terms and then I just plugged a negative z out of this, so I would be having h sub n minus this very term, that is ln of n, and then I'm having z of h sub n. And you know what, the definition of Euler Mascheroni, I'm sorry, yeah, it's fine, a Mascheroni constant, that is the gamma, small gamma actually, lowercase gamma, it is, gamma is, okay, gamma is h sub n minus ln of n. That's amazing. And that is why we did that, because we are just going to replace this with Euler-Mascheroni here, and yeah, it's fine. You can just have a look at here, I did that. Okay, next. So let's just replace it with that, and we are having that gamma of z equals limit n tends to infinity of n to the z is e to the negative z times Euler-Mascheroni and plus z sub n, z times h sub n. So basically it is e to the minus z Euler-Mascheroni and plus z h sub n over its z and times the product as k goes from 1 to n of it's, wait a second, yeah, and it's k over z plus k. Okay, yeah, it's fine. And next, since these two terms are independent of n, so we can just plug them out of the limit. So this is e to the negative Euler-Mascheroni times z over z, then limit n tends to infinity of e to the z times h sub n and times the product as k goes from 1 to n of k over z plus k. Okay, yeah, it's fine. And next, okay, so as I represented here that the h sub n equals the sum as k goes from 1 to n of 1 over k. So I can just replace this h sub n with that. So let's see what we're having here. So gamma of z equals e to the negative Euler-Mascheroni times z over z. Limit n tends to infinity of e to the z times the sum as k goes from 1 to n of 1 over k and times the product as k goes from 1 to n of k over z plus k. Yeah, it's perfectly fine. Let's use just consider putting up a big parenthesis in front of the limit. Okay, now I think I would like you to take a look at something, this part. So basically what I'm trying to say is, just take a look at this part. K goes from 1 to n of 1 over k, and this is in power of e. So it is written, it can be written as e to the sum n, k goes from 1 to n of z over k, and again this can be written as e to the z when k equals 1 plus z over 2 plus z over 3 plus dot 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 z over n, and again that can be written as independently, like being multiplied to each other like this: e to the z times e to the z over 2 times e to the z over 3 times e to the z over 4 dot 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 to e to the z over n. And we can just consider writing it in terms of a product, as k goes from 1 to n of e to the z over k. Okay, yeah, it's perfectly fine. So basically this part is the product as k goes from 1 to n of e to the z over k, right? So let's just consider writing this product over there to get something, two products relation. Okay, so basically we are having gamma of z equals e to the negative Euler-Mascheroni over times z over z, and then we are having limit n tends to infinity of, that can be represented as the sum, product as k goes from 1 to n of e to the z over k, and times the second product, that is the product as k goes from 1 to n of k over z plus k. Okay, and again these two products are just going from k equals 1 to n, so we can just consider writing it as a single product and considering these two functions being multiplied to each other. So basically again we are having gamma of z equals e to the negative Euler-Mascheroni times z over z, and then limit n tends to infinity of the product as k goes from 1 to n of so it's k over z plus k and times e to the z over k. Okay, since we are not having any kind of n here, so we don't care about infinity, so now we can just plug n in infinity right over there. So I'm having, or I'm just going to change a little bit here in these two things. I'll tell you what's that actually. Okay, yeah, that's fine. Actually, in not these two things actually, but I'm just going to change in this function only. So basically, it's again e to the negative Euler-Mascheroni times z over z, and its limit n tends to infinity. So it's the product as k goes from 1 to infinity. Well, I can write this as z plus k over k to the negative 1 e to the z over k. Okay. And actually why I did that, because in order to get something better from this, and what I would get is z over k plus 1. So that is why I did that. Or I think I should just replace here with that only. So yeah, I think I should just replace this z plus k over k as 1 plus z over k. Okay, so yeah, and next this is the second final step, and I would like to just write down the final step here. Basically you just have to take the reciprocal of all these things, these two equations. So Let me just do that here even. Let's just not leave it because that's the final step actually. And why we do that? To just get something uh, better out of it, because so far we just have learned about this gamma function, but we have never learned or listened about 1 over gamma of z. So that is why Weierstrass used his powerful brain, and what he got, 1 over gamma of z equals, so it's 1 over this part. So it's z would be on top, and this would be e to the z over e to the negative masculinity times z. So I can consider writing this in numerator as z times e to the Euler masculinity times z, because this negative would be positive if I'm just bringing that on top, and the product would be as k goes from 1 to n, and this would be like the negative power would be vanish, so that is gonna give us 1 plus z over k, and we would have a negative power here as well, e to the negative z over k. And here is the Weierstrass infinite product representation of gamma function. Well, both these two things are same, but this looks quite awesome, I think. Okay, and you know what? Actually, here something is invalid. What is that? Let me just tell you in this video only, because I'm just going to bring a video in which we would be talking about the Weierstrass infinite product, and we would be talking about this one. So